So the previous video we have seen that we could set up VGW and also make IPSEC VPN connection, right? Now what we are going to do in this video is adjust the routing in such a way that we have reachability. Now everything is documented within this page, and I'll share this particular page in the description section. So let's go to the part 3 of this setup, and there are few things that I would like to mention here. In this case, the end-to-end topology is something like this, right? So we'll set up a EC2, which will be our client PC behind VGW, and this will be in 10/24 subnet. It connects to the VGW through the VPC, and now we'll try to send the encrypted traffic from the VPN server to the EC2 client. So first we'll test it with the VPN server. It has to reach the EC2, and then what we'll do is a similar to production setup where we'll set up VPN client on the premises to go through the server, right? So let's test it from the server's perspective. So the server is 192.168.1.200, and as of now it's not pinging, which is okay. There are few things that needs to be taken care of. The first and foremost thing that you need to take care of is adjust the routing. In a way, you need to make sure that the VGW route propagation is set to yes. Now let's select the VPC. We have the routes. There is an old route which is sitting there. The VGW is no longer there, and it is showing its black hole. That's fine. We go to route propagation, and the propagation is set to no. So you need to turn this to yes in order for VGW to send in the routes into the VPC routing table. So let's do it. I'll enable it. And as soon as we do it, we should see the route which we configured to be advertised into VPC should appear here, which in this case it is 192.168.1.0 is the Frankfurt subnet, and we can see that it starts pinging straight away, right? So the VPN server can reach this particular EC2 client just fine. Let's try it from the other end, which is obviously there. So this completes the server reaching out to the EC2 client behind the VGW through the IPSEC tunnel. Now we do know that there are a couple of CloudWatch metrics that are associated to it, right? So if you go into CloudWatch, there are a lot of them. Probably there are 3 major of them. So one is tunnel status, tunnel state, tunnel data in, and tunnel data out. Let me try to get these details. So let's go to CloudWatch. We'll go to metrics, all metrics. In here we'll go to VPN. In VPN we'll go to VPN tunnel metrics, and here I have throughout the days I have configured multiple tunnels. That's the reason why you see a lot of them with a lot of numbers. In our case, I don't remember the IP address that is on top of my head. So what I'll probably do is let me add it to the graph. So let's go to EC2 running. So it should be the public IP. We should have something with the public IP of the Frankfurt server. Let's see if we can straight away search that. I doubt if we can, but let's try to search with the IP, and obviously cannot do a straight search. The way you have to do it is click on it and add it to the metrics, and that way it gets added to the graph, right? Now we can see that all of them are for the tunnel state. Let's add it to the graph. We can see out of many things there is only one particular IP which is currently up. There is only one tunnel which is up, and that's with 18.203 address, right? And if I select all the things, then you can see that there are so many IP addresses which are currently being up. So these are nothing but this should be the tunnel public IP address, which is up. So let's verify it. So we'll go into VPC and we go to site to site. Here we can see the tunnels. Let's say tunnels, and the one which is up is exactly the same address. So that's the one which we can see that it is already up and active. There are other two metrics as well. So the number of bytes that come into the tunnel and leave the tunnel as well. So let's see if that can be searched. So I'm trying to like do a casual search, see if it comes in. I don't think it is. So let's see the accurate metrics. So it's tunnel data in. Can I get with tunnel data in? No, still. So you have to like cancel everything, go back to the metrics and select the same way that we did it before. So add that to the graph. Now we can see a couple of metrics that started to shoot out. So in order to like less complicate the things, what we can directly do is like select all of the metrics that are available for you. So you can see various metrics that are mentioned there. So I just selected everything, and you can see two of the other metrics started to pop up: tunnel bytes in and tunnel bytes out. You can configure CloudWatch to have alarm around these particular metrics, and you can have alert conditions and then like take some actions with respect to tunnels going down and how it can be achieved. So that's one part of it which is solved. The last part of the equation, which resembles like having a server on EC2 instead of VGW itself, is like having a client behind the server, and we need to figure out like how do we influence that particular decision. So let's go back to the topology. So our intention every time when something is connected to VPC, right, the logical flow is it always hits the VPC first. So irrespective of like however the diagram depicts, the intention is like that's the where the termination point is on the server. So client sends the traffic and traffic gets encrypted from the client, and first it flows to the VPC, and from VPC is the one which maintains and connects all the routing table. So we need to have a route which says, okay, any traffic that you see for 10/24 subnet, send it back to VPN server instance, and it will know how to figure it out. The way it can like route it, because the net IPv4 forwarding has been enabled to true, so that will successfully be able to route it. So let's go to the VPC. So once we go to the VPC, we need to make sure again that it flows through the server, because VPN is terminating on VPN server while VGW has termination on itself. So wherever you have the termination points, you need to make sure that traffic comes to the termination point, because that's how the traffic from there gets encrypted. Only server knows how to encrypt, because that's the one which has the tunnel and routing information. So I have a termination point on VPN server. I just need to make sure that client sends the traffic to the VPC. In this case, VPC has a route which points back to the server for the destination subnet. Server is enabled with IPv4 forwarding, so it should be like straightforward in this case. So let's go and like try to like edit it for the destination 10/24. There should not be a real tricky, because like we already have everything in place. We already have server like with reachability. It's just a point of how we make the client reach the subnet. So we go to Frankfurt instances, we choose the subnet. Do I do this here? No. This is where you have route table associations. Probably I should come back. Should I do it in the VPCs? I don't think so, right? Like the place where you do this is route tables straight away, right? That's where you edit it. So you go into the route tables, you choose the VPC, you have the routes, you edit the instance, you add a route. You say for 10.0.0.0, you can be more specific or you can be less specific. It's completely up to you. And I would say instance is VPN server, and that's about it. Now you have the route. Probably it will take a couple of seconds more before it starts reflecting in ICMP. No, it seems to be no response. Did we do anything wrong? Let me exit out of this server. Let me hop into the client directly. See if I can reach the 10 network. Don't seem to do that. The reason why you're not able to have the reachability is because every EC2 instance comes with a restriction. It says if the instance or connected interfaces are not generating the traffic, then don't forward it. And it is very easy to disable the check. So you go into the actions, networking, change source and destination check. You can see the description there. It exactly says the same. So you need to disable this particular check so that EC2 in itself would start allowing it. And the moment we do that, it clearly says, right, this is being redirected from VPC back to the server and we have the connectivity back. Why is that the 10 instance is not able to ping? The reason 10 instance is not able to ping, do you need source and destination check on the 10/16 instance? No. The short answer is no, because you need to stop this source and destination check when you have traffic not originating from your instance. That's not the case on the EC2 client, right? It's a single instance. It's connected directly to the VPC. It doesn't have any client switch forwarding the traffic. It's a security group. You just need to go ahead and allow ICMP. And the moment you allow ICMP, it should start pinging. And that's the reason why it was blocked. So we have end-to-end reachability. We have everything working and flowing freely. So it was fun doing this lab, and next iteration we'll try to explore the dynamic nature of BGP in IPSEC VPN and explore how BGP will be used and the different metrics that are associated when doing it with BGP. Thank you so much.